Okay, this how-to video is going to talk about clash detecting in PCB Editor. So this is something that's available in all levels of the tool, so OrCAD PCB Designer Standard, Professional, and in the Allegro PCB Designer. And what it does is allow you to do step model clash detecting. So I've got a couple of examples just to run through here quickly. It's all done in the 3D canvas, and effectively you would map step models to, or associate step models to all of your PCB footprints. There's other videos showing you how to do that. And then once you have that, we'll then go to the 3D canvas. So in the 3D canvas, let's just set up the colours. So let's just use Steve's test one. Okay, fine. So I've got a 3D visual representation of my PCB using all the step models. I've got an imported step model cover. This is done using a mechanical part, and I've brought that into the design and placed that. So now I've done that, I've actually got a collision detection tab inside the 3D canvas, and I can then go and calculate. Now what this does is this actually compares step model to step model, and does any clashes that it finds, and it will then report those. So it's found 3. If I look here, so I've got some issues. I've got a couple of issues with my cover and an issue with a mechanical part. So we'll look at the cover. I can select the cover and it will then highlight the cover. So obviously this is the cover that's causing an issue, and it's clashing with D4. Obviously it's going to highlight this in an orange colour here, and you can see physically that my LED here has been misplaced, so it's not placed directly into the cutout. If we look here, we're causing an issue here. You can see this one is clear, this one is not. If you have problems locating these, you can actually right mouse button on the item and do locate, and it will then flash the component for you 5 times, so you can then locate the part much easier. So I've got a couple of instances of this of D2 and D4, so these two are clashing. And if we then actually just clear over, what we'll do is we'll turn the board over, look at the back side of the PCB. So I've got a connector placed here, and I've actually got a step model of a DIMM module that's been effectively placed in here, and I've actually got a clash between these two parts. This is what they class as an interference fit, so it's actually going to show me that they are interfering, they are touching from that point of view. So that's effectively one example of the step model. I'm going to open a second board, so we'll do File Open. We're just going to open a slightly different example. So in this example, I've got a kind of a flexi design here. So I've got some rigid sections, 4 rigid sections, 3 flexis. So we'll go to the 3D view. I'm just going to hide the top cover or the case, and then what we'll do is we'll actually bend these. So we'll go into the bend mode and bend all the flexis, which will make effectively like a stack of PCBs. So you can see I've got a stack there of all the PCBs. So we then go to the clash detector, click on calculate, and I actually get an issue between U24 and U5. So we can actually look at these. So I've got an issue in here. So let's just zoom in, and you can see this. So when this is flat, obviously I wouldn't see a clash, but now I've bent these. So I've bent the radius. Or bent the flexi. I'm actually clashing components here, so the clash detect works even when you actually start to do bending inside the tools.